Okay, so the main focus of this chapter is going to be to graph all of our trig functions. Okay, so let's first talk about what it means for a function to be a periodic function. And what we're going to notice is we're going to discover that all trig functions are periodic, which is kind of to our advantage. So let's define what a periodic function is. So we'd say a function is called periodic when it starts repeating itself after some distance p. So that is f of t equals to f of t plus p. So what are we saying here? The y values of this function will be the same as the y values of that same x value, but added a p, some distance p to it, which p is known as its period. So let me show you just really quickly visually what that means. So what we're saying is if you keep moving, if you start from a point or a value t, and if you keep moving a distance of p away, the y values will be the same, which means it's repeating basically. So if I give you a graph that looks something like this, for instance, and this is clearly periodic. Why? Because it keeps repeating itself over and over and over. So if I pick this point, call this t, and then I travel a distance of p, notice how this is t plus p, and notice how the y values are the same. And if I were to continue this on, and it doesn't matter which point you pick, if I pick this point, notice that that distance I travel p, this distance and this distance are the same, so it starts repeating itself every single time. So that's basically kind of what a periodic function is. So in other words, if you could graph one period of the function, then you know exactly how it looks because it's going to repeat itself over and over and over. So one comment I want to make, which is going to be to our advantage, is that all trig functions are periodic, which is going to be nice, because what we're then going to say is, well, if I could graph one period of this trig function, then I basically have generated its graph. So the focus of this section is going to be to graph, we're going to be graphing f of t equals to sine of t, and f of t is going to equals to cosine of t. So these are the two trig functions I want to graph. So before we do that, let's first talk about their characteristics. So we care about the characteristics of f of t equals to sine t and f of t equals to cosine of t. Okay, so let's talk about the domain. And if you remember, we did mention this last chapter, but the domain of sine and cosine is all real numbers. So this is for both. So we know that this will never ever be undefined. So the graph exists for all real numbers, okay? And then the range, and I'll explain to you why the range is what it is. The range of sine and cosine is from -1 to 1. So what I'm telling you is the graph of sine of t and cosine of t is just going to be always between -1 and 1. And the smallest it could be is -1, the largest it could be is 1. And this is obviously for both as well. So let me kind of explain to you guys why this ends up being -1 to 1. We could say, look, notice that cosine of t by definition is x over r, and sine of t is y over r, right? That we know from previous chapters. So since r is the hypotenuse of our right triangle. So what is it that we know? R, if you remember when we drew the x, y, and r, other than quadrantals of course, but outside of that, when we drew x, y, and r is always the hypotenuse of our right triangle. And what do we know about the hypotenuse? That's the longest leg, it's the longest side. So since r is the hypotenuse of our triangle, then we know that then x over r and y over r will either be between plus or minus 1, right? That's when we have our right triangles, because what do I know? X and y are both going to be smaller numbers than r. So if x and y are smaller than r, what do we know? Our number is going to be between plus or minus 1. And it'll be in the negatives if x and y are negative, okay? So that or will equal to 1. And when will that equal to 1? When we get quadrantals, and what do we know? X and y end up being the same values as r, or they end up being the opposite of r. So this is when y equals to plus or minus r, or x equals to plus or minus r. And when does this happen? So look, let me show you. This happens when we have quadrantals. So look, for instance, if I draw, I don't know, 90 degrees or pi over 2, what are the coordinates of this point? 0, 1. So notice how this is 1. So r is 1 and y is 1. And that's when you'll get 1 over 1. Okay? And then, or if you go this way, if I were to get 3 pi over 2, what are the coordinates at that point? 0, negative 1. R is still 1, but now my y value is negative 1. So those are the instances where you can get negative 1s and 1s. Other than that, your values are always going to be between negative 1 and 1. And of course, we also have the quadrantals that land here, where x is 1, y is 0, and then x is 0, negative 1. Okay? Or sorry, x is negative 1, y is 0. Right? So that's when we have like these specific cases. So let's now, so what does that basically mean here? We notice that, hey, since we saw that the largest x and y could be 1, so we would say that the maximum value of sine of t equals to 1 and cosine of t equals to 1. So those are the maximum values. And then the minimum value for sine of t is negative 1, and for cosine of t is also negative 1. So we know that sine and cosine will never be any larger than 1, and they'll never be any smaller than negative 1. Okay, so now let's also talk about the symmetry, because when we graph it, we'll see that there is some symmetry. Sine of t is an odd function, which means what? It means that it's symmetric with respect to the origin. So what does that mean if something is symmetric with respect to the origin? It just means that whatever it does to the right of the origin, it does the exact opposite to the left of the origin. So notice how it's going up, then down, then over here it goes down, then up. So that's kind of how the graph of sine looks, which in other words, what does that imply? If it's symmetric with respect to the origin, we know that sine of negative t is the same thing as negative sine of t, right? That's a fact. That's what it means when it's symmetric with respect to the origin. Okay, so then we also have cosine of t is even, which means that means if it's even, it's symmetric with respect to the y-axis. So when we graph it, what does that mean? the y-axis is kind of like the axis of symmetry, so it kind of just repeats, or it's like a mirror. The y-axis mirrors this. Okay, and then what does that also imply? That implies that if it's even, cosine of negative t is equal to cosine of t. Okay, now the next thing I want to talk about is the zeros. So sine of t equals to 0 when? Well, if you look at this, if I come back up here, sine of t will be 0 when y is 0, because remember, sine is y over r. So notice how sine is 0 at 0, pi, 2 pi, 3 pi. So we would basically say sine of t is 0 when t equals to pi k. So in other words, we're saying we want to land here or here, because if you notice, this point has coordinates 1, 0. This point has coordinates negative 1, 0. And we know that sine of t is defined as y over r, which in these cases here with 0, pi, 2 pi, 3 pi, 4 pi, notice how I just keep jumping around. Those cases will have a y value of 0 over 1, for instance, right? That's basically, and my r is always 1 here, so it's 0. So now if we look at cosine of t, when will that equal to 0? Well, that equals to 0 when, so if I kind of, let's work backwards, if I'm up here, like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. How come? Because that point has coordinates 0, 1. This point has coordinates 0, negative 1. And once again, cosine of t, by definition, is x over r. So over here, notice how x is 0, r is 1, which gives me 0. So that would be when t equals to pi over 2 plus pi k. Now, why do I keep adding pi? Because to go from here to here, that's a distance of pi, right? That's how we go there. So with that said, let's look at our first example. Okay, so for example 1, we're going to say use the characteristic of f of t equals sine t and f of t equals to cosine of t to evaluate. So the first one is t equals to pi over 4 plus 4 pi. So for this one, we're going to say find f of t equals to cosine of t. So then what is it? We have, if I have f, so of pi over 4 plus 4 pi, that becomes cosine of pi over 4 plus 4 pi. But if you notice, every time we add 2 pi, we end up in the same place. So if I'm adding 4 pi, I end up in the same place as pi over 4. So that means I could say this is the same thing as cosine of pi over 4. And I could easily find that, right? I mean, not that these two are any different, because this one just puts you in circles more. But if we're talking about cosine of pi over 4, that puts us there. That's a 45-degree reference angle, so it'll be 1, 1 rad 2. So it ends up being 1 over rad 2 or rad 2 over 2. Okay? Now, for part B, t is negative pi over 3. So we could say f of t, find f of t, which is sine of t. In this case, we have f of negative pi over 3, which is sine of negative pi over 3. One characteristic I could use, if you remember, we said sine is an odd function. So what do we say? Sine of negative pi over 2 with pi over 3 would be the same thing as negative sine of pi over 3. So I could find that, and I could use this because it's an odd function. So sine of pi over 3, so pi over 3 would be what? A 60-degree reference angle. So this would be 1 rad 3, 2. So sine is y over r, so it'll be rad 3 over 2. Okay? So now let's actually get into graphing sine and cosine. Okay, so if I'm basically going to be graphing f of t equals to sine of t, and f of t equals to cosine of t. The good news here is we're going to be using specific key values to when graphing. So, and these will never change. We'll always keep this the way it is. So just make sure to always use these values. So we'll say that when graphing sine of t and cosine of t, we will always use the following key values. Okay, so these are the key values we want to use, and we're always going to use this for sine and cosine, okay? Which is t equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so and notice how I'll make a comment on this, but these are nice values. Why? Because they're quadrantal. So what do I know? Sine and cosine are either going to be 0, 1, or -1. And this will do a good enough job of getting us to see what the graph looks like. Okay, so this is what we want to do. And a comment I want to make here is that notice these values start from 0 and end at 2 pi. Which, notice how this is a distance of 2 pi, right? So if this is a distance of 2 pi, that allows us to capture one period of sine and cosine. And the other good news is, and they are quadrantals, which means we're not going to get ugly looking numbers. It's either we're going to get 0, -1, 1, like those are the types of numbers we're going to get. Okay, so let's actually start off with sketching a graph. So we would say, for example 2, graph f of t equals to sine of t and f of t equals to cosine of t. Okay, so let's do this. So to do this, I'm going to create a table, right? To me, that's the easiest way to go about this. So this is my input, my output is f of t. So we said our inputs are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi. So if I use kind of like a table to help me, 0 would put me where? There, which has coordinates 1, 0. So sine of 0 is y over r. So remember, r is always going to be 1 in this case. So it'll be 0 over 1, which is 0. Okay. Now pi over 2 puts me up there. That'll be 0, 1. So sine of pi over 2 is what? Y over r. So y is 1, r is 1, 1 over 1, which is 1. Sine of pi, -1, 0. Once again, it's 0 over 1, which is 0. 3 pi over 2 is 0, -1, which would be what? -1 over 1, so that's -1. Okay, hopefully you guys see what I'm doing here. I'm just still using the x, y, and r ideas here. And then 2 pi brings me back there, which is 0. Okay, so I've been able to force out one period of pi. Now here's the good news. When we're graphing this, by the way, we want to be in radian measure, because when you're in radian measure, you don't need to go around, and we don't want to move in circles. We want to move along the x-axis. Now the good news is 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2, 2 pi. These are all equally spaced out. And since they're all equally spaced out, I'm going to say, look, I'm calling this distance pi over 2. And you guys could do this too. Just make sure you stay consistent. So if that's pi over 2, that's pi. Notice how I'm trying to keep my spacing the same. 3 pi over 2, 2 pi. And this will get us one period of sine. So at 0, it's 0. At pi over 2, it has a y value of 1. At pi, it's 0. At 3 pi over 2, it's -1. At 2 pi, it's 0. So now I've graphed one period of sine. But the good news is, if I said, hey, graph another period, you just continue on, right? It's after this is going to repeat. So what is it going to do? It's going to go up again, come down, and up, right? So once you graph one period, you could graph 10 for all you care, right? It really doesn't matter. Now, let's also graph cosine of t and see how that looks. And I'll use the same table right here, I guess, these points to help me out with cosine, since they're using the same exact inputs. So we're going to be using 0, pi over 2, pi, 3 pi over 2, 2 pi. Except when t is 0, it puts me there. Now remember, these are the angles that I'm rotating, right? Because 0, pi over 2, pi, 3 pi over 2, 2 pi, right? I'm just rotating around. So if t is 0, that means I end up here. That's for cosine, it's x over r. X is 1, r is 1. That gives me 1. At pi over 2, puts us up here. X is 0, 0 over 1 is 0. At pi, x is negative 1, negative 1 over 1 is negative 1. 3 pi over 2, x is 0, 0 over 1 is 0. At 2 pi, it brings me back all the way here, which is 1 over 1, that's 1. Okay, so now I'm ready to graph this, which if I'm graphing this, this will be 0, pi over 2, pi, 3 pi over 2, 2 pi. So at 0 it's 1, pi over 2 it's 0, pi it's negative 1, 3 pi over 2 is 0, 2 pi it's 1. And notice how when I'm creating my graphs, I'm not making it like, it doesn't have any corners. It's always rounded and curved. So always remember that. Your graphs, notice here, it's always curved and rounded, okay? Never do it like a zigzag, like it's never like that, okay? It's always rounded and curved, okay? So now what we're going to do is we're going to basically graph. So we're going to be graphing y equals to a sine bt and y equals a cosine of bt. So with the a's and b's, all it does is it kind of stretches this vertically or compresses it, and then this stretches it stretches it horizontally or compresses it. So let's kind of make a comment on what happens. But if we can just graph sine of t and cosine of t, the other stuff is pretty straightforward. So we'll use transformations to graph this, and you'll see what I mean once in a minute. So we're going to say, look, a and b change the maximum, minimum, and the period of sine and cosine. Okay, so let's talk about the a first here. Okay, so the absolute value of a, that represents the amplitude of sine and cosine. And then we could say this, so when we talk about the amplitude, so this is the distance we travel up and down from the horizontal line that cuts sine and cosine in half in order to get to the maximum and minimum. So, for example, a quick example would be if I gave you the graph of 2 sine of t. See, what's this 2 saying? You're multiplying all the y values by 2. So the graph would look something like this, let's say, where that maximum becomes 2, the minimum becomes negative 2. But the amplitude, just because this is 2 and negative 2, it doesn't mean the amplitude is 2. It just so happens to be that in case, because if you think about which horizontal line cuts this in half, it's the x-axis. Now look, from the x-axis I go up 2 units and I go down 2 units to get to the maximum minimum. So just keep that in mind. In this case, it's the x-axis that happens to cut it in half. So that's how you know what the amplitude is, by looking at kind of what the halfway line is. Okay, now what does B help us do? So B helps us find the period of sine and cosine. Okay, so the period is found by P equals to 2 pi over B. Now if you remember the first example we did, or the last example we just did where we graphed sine and cosine, B was 1. And notice if B is 1, 2 pi over 1, that gives me a period of 2 pi. So that's basically what it is. Now if B is something other than 1, our period will change. Okay, so what we could say is, and that's the comment I'm going to make here next. So the comment I just made, don't worry about it, we're going to write it down. So notice for f of t equals to sine of t and f of t equals to cosine of t, b equals to 1, right? Because look, the number in front of this t, there's nothing there, which means we assume it's a 1. So if that's the case, b equals to 1, this implies the period is 2 pi over 1, which is 2 pi. Okay? So if the period of sine or cosine is something other than 2 pi, we then need to adjust the key values. Okay, and that's actually not difficult to do, is because I'll show you this will be done by setting bt equal to 0 pi over 2 pi 3 pi over 2 2 pi, and what we're going to do is, and we're going to solve for t. And where is this bt coming from, by the way, if you're wondering? This bt, if I come back all the way up here, notice how it's that, because my angle is no longer just t, it's bt. Okay, so that's what we're doing here. We're setting bt equal to each one of these, so then we could solve for t, and you'll see that that will give t equals to 0 pi over 2 over b, pi over b, 3 pi over 2 over b, and 2 pi over b, which basically, what is this saying? Just divide all your key values by b, and that'll get you our new key points, which will be our new key points. Okay, so let's actually do that, and in fact you don't really even need to do that. I'll show you a nice clean way of doing this. So for example 3, there's 2 parts, there's 2 sketches. Maybe you might want to do one with me, and then you could pause the video and do it on your own and then check your answer with mine. So draw a sketch of f of t equals to 2 sine of t for t in the interval from 0 to 2 pi. So here's what we're going to do. I'm not going to worry about graphing 2 sine t. I'm going to graph sine of t, because we just know that's our basic graph, and that's very easy to do. So if you remember, and you don't have to write down the table like I did earlier. You could just go ahead and sketch it by hand. At some point you'll get used to these values so frequently where you can work with them. But if not, you could make a table. So if you remember, we know that sine of t at 0 was 0, at pi over 2 was 1, at pi it was 0, 3 pi over 2 was -1, 2 pi was 0. So that's what this graph is. Now, if I know what the graph of sine of t looks like, which is this, then graphing 2 sine of t should be very easy, because what is this 2 saying? Grab all your y values and multiply them by 2. So since the y values are changing, the x shouldn't change. So what do I know? Over here, my y value was 0. When I multiply it by 2, it'll still be 0. At pi over 2, my y value was 1. So if I multiply it by 2, I get 2. At pi, my y value was 0. If I multiply it by 2, it's still 0. At 3 pi over 2, my y value was -1. If I multiply it by -2, or by 2, it'll give me -2. And at 2 pi, it was 0. So notice how what happened to my graph here compared to there. It got stretched vertically. So I just started with the graph of sine of t, and I used transformations to create the graph of 2 sine of t. And I recommend that you guys do that. That's the easiest way to go about it. Now, how about the next one, b, which is saying f of t is equal to -3 cosine of 2t. Okay, so once again, instead of graphing -3 cosine of 2t all at once, I'll start off by graphing cosine of t, which then, if you remember, this was 0, pi over 2, pi, 3 pi over 2, 2 pi. And we just want to keep the spacing the same. If you remember, cosine at 0 was 1, at pi over 2 was 0, at pi was -1, 3 pi over 2, 0, 2 pi was 1. So here's one period of cosine. And then I could now say, okay, I'm going to take care of the -3 first. So this becomes -3 cosine of t. So what's the -3 saying? Grab all your y values and multiply them by a -3. So at 0, it was 1. 1 times -3 now puts you at -3. At pi over 2, it was 0. Pi over 2 times, or 0 times -3 is still -3. At pi, my y value is -1. -1 times -3 is +3. And then 3 pi over 2 was 0. 0 times -3 is still 0. At 2 pi, it was 1. 1 times -3 is -3. So notice how it got stretched upward. Okay? Now, the last thing I need to do is take care of this 2t. So now, -3 cosine of 2t. What is this saying? If you remember earlier on, what do we say? The way we adjust the x value. So now this is affecting our t values, or the x values, that as we call them. This is saying grab all of your x values and cut them in half, or multiply them by 1/2. So how's that going to change? Well, if I grab, this has an x value of 0. If I multiply 0 by 1/2, it's still going to be 0. This is pi over 2. If I grab the pi over 2, multiply it by 1/2, it becomes pi over 4. And the x value, or the y value, doesn't change. It's still 0. So this is saying only multiply your x values. So if I take pi, multiply it by 1/2, I get pi over 2. And at pi over pi, our y value was 3. Now at pi over 2, my y value will be 3. So notice how the y values aren't changing, only the x values are. So this has a y value of 0, but its x value is 3 pi over 2. If I multiply 3 pi over 2 by 1/2, I get 3 pi over 4. And then at 2 pi, if I multiply it by 1/2, I get pi, which the y value was -3 and so this graph now becomes like that. So it's kind of like from here to here it's squished, okay? So notice how the 2 created my period to be pi, and notice how 2 pi over 2 is pi. Notice how that adjustment works out nice and convenient. Okay, so I would say if you know how to graph the graph of cosine, then you could perform any of them. It's just I would prefer to take things step by step and take each transformation separately, which will make it a lot easier to graph. Okay, so let's look at our last example, and this one we're going to be working backwards. So, or this is example 4. The graph of the form y equals to a sine of bt. So they're telling us that this is the function is given. Find a and b. So we're trying to find a and b. So first let me give you the graph. So the graph is this. So this is 4, negative 4. That's pi over 2. Pi, 3 pi over 2. Okay. All right. So I think we have enough information to figure this out. Well, to find a should be the easy part, because if you think about it, what horizontal line cuts this in half? It's the x-axis. So from the x-axis, how much do I have to travel up and down to get to the maximum minimum? And that means a is 4, right? Because I'm traveling up and down 4 units. Now, to find b, I need to find the period. And what is the period of this? If you notice, when does this start repeating? We start at 0, we travel this. So notice how this is one period. This is one period. What's that distance? If you look at it, that's a distance of 3 pi over 2. And in fact, this would be negative 3 pi over 2. So notice from here to here, you travel 3 pi over 2, 3 pi over 2. So we know that the period is 3 pi over 2. Now, how could I use the period to help me find b? Well, if you remember, the formula was what? Period equals to 2 pi over b. So that's the formula. We have p, which if I replace p with 3 pi over 2, I'll do it down here. I'm running out of space. 3 pi over 2 equals to 2 pi over b. Now I could solve for b. If I cross multiply, I get 3 pi b equals to 4 pi. Now to find b, just divide both sides by 3 pi. And what does that give me? B is, the pi's will cancel out, 4 over 3. And there you have it. Okay, so in this section, all we really did was talk about the graphs of sine and cosine. We learned how to graph them. So you will have lots of practice for homework regarding this stuff. So just also please be sure to reach out to me if you have any questions. And also I highly recommend you attend my office hours if you have any questions regarding the stuff we talked about today.